Hello, everybody. We are back after that break of 1 hour. I hope you have rest. I hope you are enjoying the hackathon, and I hope you are enjoying as well the conferences. It's a pleasure and a honor for me to present to you Belén Lorente, who is Global Data Scientist at Nespresso. Belén is a mathematician with more than 10 years of experience as a data scientist in genomics and neuroscience. She is well versed in numerous programming languages, including R, Perl, Bash, PHP, SQL, and more. Moreover, she is the co-author of 25 papers published in the international peer-reviewed journals, 5 of them in Nature, Science, or Cell, 3 as the first author, and 1 book chapter. Belén, thank you very much for joining us today. How are you? It's up to you. You can start talking whenever you want.
Okay, thank you so much, Noelia. Thank you for the invitation and for giving me this opportunity to talk and to be here today. I will start sharing my computer now. Let me see, wait a moment.
I will confirm when we can see your screen. Don't worry.
Okay, perfect. Are you there?
I confirm. Yeah, we can see.
Okay, perfect. So the title of my talk today is Genomics, Coffee, and Newton. First of all, genomics, because this is what I've been doing almost most of my career. Coffee, because this is what I'm doing right now, but only for 3 months or 4 months. And Newton, you'll see soon why Newton. So here there is the outline of my talk, just for you to know what you can expect. Uh, I divided it in 2 parts. My first part is about my professional journey. Um, I will share reflections and my own learnings, and this is where I'm going to talk a little bit about Newton, the Newton Raphson. You'll see why. And the second part, I'm going to just stop a little bit of what I've been doing specifically as a data scientist. So let me. This is who am I? A very first and rapid, quick description of what I've been doing during my career. I studied the mathematics bachelor. Then I decided to do a master in bioinformatics, and then I spent 3 or 4 years doing a PhD in biomedicine, followed by, I don't know if it was like 2 different postdocs, one here in Barcelona in the evolutionary biology unit of the Pompeu Fabra University. And then we moved to the United States for 4 years, to the Yale University, to the Department of Neuroscience. Then we came back, and I decided that I wanted to make a change and go to work to a company. For that, I did a master, so I could learn which tools were the usual used in the companies, apply it to big data management, technologies, and analytics in the Polytechnic University of Barcelona. And finally, here I am since October working as a global data scientist in Nespresso. So, those are the facts of my professional journey, but I would like to share my impressions of how this path was done. First of all, you'll see that I haven't put it like step by step, like a staircase, instead it was like different steps. So when I was preparing this talk, and how I wanted to explain this professional journey, I remember about this method, Newton-Raphson method. It is probable that many people that is hearing this today, you already know about this method, but let me review it with you right now. Imagine that we have Imagine that we have a function and we want to know the exact roots. The exact roots are the points in the x-axis where the function is equal to 0. So it will be here at that point in this case, in this example. So the idea of the method is that sometimes it's very difficult to find it, like there is not a formula. And then we need some methods, numeric methods that allow us to approximate to the solution. So the idea in this case, this method of there are different methods that they can do similar things, but the idea of this one is that you start with an initial point and then you move to what is its value in the function. At that point, you do a tangent. You look at the tangent and where it intercepts with the x-axis. This will be your second point, the second iteration. You do that and you go what the value in the fx in the f, in the f function, and then you do the tangent, and you keep doing that several iterations, and then finally after it will converge in a root. So two facts about this method is that it really depends on the starting point. Where you start here, you maybe arrive to this exact root. But if the function is different, um, depending on if you choose another start point, you will end up probably in another uh, root. And also there are cases when it is not convergent. So we can apply that. Imagine that we have a function when there are local maximums, there are also local minimum, but I'm going to focus on the maximum because this is what I'm interested on today. And a way to find this local maximum will be to find the roots of its derivative function, right? So and we could do that with the method of Newton-Raphson method, as I explained before. Those will be the minimum, but again, I'm not interested in that today. There are ways to differentiate between minimum and maximum, you know that. So what is the link between this, why I'm talking about Newton, and my professional journey? Well, so if when I was thinking about that, I was thinking, so if we consider this function as where are you in your career and being the maximum possible successes, like success in your career, I will say that first of all, it's really important where you start, the initial knowledge you have, your background, your family. So I will say that in my case, particularly, I started. So my father, he is an engineer, but more importantly, my mom, she is the first woman being registered as an architect in Vizcaya. Vizcaya is a region of the Basque Country. She was, in fact, like in 1967, there was the first woman registered architect in the Basque Country, and in 1971 there were four in the Basque Country, and she was one of them. And I think she told me that when she finished her career, there were only 6 or 7 women, and the rest were men. I grew up. Not only her, she is the eldest sibling of another 7. Um, she has 7 siblings, and all of them have all of them minus one, they have technical careers, engineers, architects. One is she's computational. So I grew up in a family where almost everybody was doing technical careers. So in my case, probably I started in a point here where it will end up probably in a technical career. It was normal to me. I never thought I couldn't do it as a woman. So, but honestly, what I was going to do at that moment, I wanted to do math. I was going to apply for architecture. But luck, which is another factor, it's important, I think, really important, and I think everybody will agree, end up being that my neighbors were uh, are teachers they belong to the University of Barcelona in mathematics. They are professors there. So they showed me the I didn't want to do mathematics, even if I love it, because I thought that the only possible job afterwards would be to be a teacher in a school, and I didn't want to do that. But they showed me that there are lots of things that can be done with mathematics. In fact, it's one of the careers that there are less people without a job. So I went there and I decided to do mathematics, and I haven't ever. I say it's luck because I think I took the correct decision in my case. So let me say something also. Like when I'm talking about this start point, I'm pretty sure there is people that they already know what they want to be. They already know. They already know what is their path, and it's much more straightforward. In my case, as you see, and that's why I wanted to show it always like that one with this method, and it was not so straightforward. I've been always asking myself what I like, where I'm going, and maybe these people that they are straight, they know exactly what they want, their start point is closer to a route, right? um in my case, I've been asking myself and learning every time, every step in the path. I've been asking myself, this is what I really want to do, what I'm doing. So when I finished my bachelor, I decided to go for a master in bioinformatics. I met computational stuff in the career, in fact, um, and I love it. I love to compute and to program, but I didn't know what to do. So I found this master where it was about analyzing the genome, analyzing genomes, um, well, applying computation to biology, in fact. Um, and I like how it sounds, although I didn't even know. I have very few or very little background in biology. But I started there, I did the master, and then I started working on the University of Pompeu Fabra, where I spent the next um, 6 years, I don't know, many years doing the PhD, well, the master, the PhD, and a postdoc. I spent around 14 years doing research. I learned many techniques in data how to analyze data. And then we moved to the United States to a group, pioneer group of neuroscience at the University of Yale. And then there also I learned new things. I Even though I have my doubts about if I wanted to be keep doing research, I always try to do my best. And that's why I'm talking about dedication. In this professional path, it's really important also dedication. Um, so we came back to Barcelona, and I decided that I want to make a different move. So to move from the academia to a company is not an easy step. That's why I decided to do this master, and it worked for me because then one of my colleagues, he was working at Nespresso, and he was able to he told me about the position there, and then I applied. Um, so the last point on this career, I will say that it's important is to always be wanting, even if you don't know what, sometimes you don't know what you don't want. Or let me say it again. So sometimes you learn, you don't know what you want, but sometimes with experience, you keep learning what you don't like or what you don't want. And then you go to the next step of your career. Um, to have a nonconformist attitude, even if you are getting older, or I think is also really important. We need to fight for what it makes you happier. When we talk about success here, to me, success, um, it's more about doing what I like, and that's why I'm talking about all this. Then it's very success is very relative, right? It's not objective in my case, and that's why also I wanted to talk about local maximum and not global maximum, because you don't ever know if you could be in a position that you will be even better, right? So, on in all this that I'm talking about, I think it's not a big issue if I'm a woman or a man. I think all of this it work for men and women. Um, but it's true that there has been moments in my career where I saw uh, prejudices because I'm for being a woman. But still, I believe that you can. I ignore them and just work. Dedication, what I was talking about, dedication, and you can be working there, even if there are more prejudices in different in some jobs more than in others, right? um, but what is the deal breaker for me really in terms of equality? So it's maternity for sure, to me at least in my experience. Why maternity? So let me show you this article, these two articles. They observe that pregnancy makes leads to a pronounced gray matter volume reductions in the mother's brain. So they compare the brain with neuroimaging, the main of women before and after having a baby, before and after a pregnancy, and they observed that the gray matter was reduced, and they were probably they associated this reduction in gray matter with the bond you do with your baby, towards your baby, right? And they compare also with the fathers. If it happens something like that, they don't observe anything like that. So, when to me, one of the most difficult or overwhelming moments in my career was when I wanted to be a mother for the first time. I was a mother, and it's really difficult to be a good mother, to be a good wife, to be a good worker, to keep focus. Um, Usually, women or the mother, um, we lost our focus because we have so many things to do, conciliate everything, and usually, or it's most common that the men, even if they also the father, if um, they they have more responsibilities, and they have more things to do, and they are not working the same that before they were father. Okay, but they, in a way, they keep their focus there. They keep their focus on their career, not as us, not at many of us, at least in my experience. It was what happened to me. um, it was really difficult, and I want to say that, um, to be able so let me say something. So, we when we came back from the United States, my husband, he was the first one who told me, this is your moment. If you want to make this move, this is your moment. Try, took 1 year, do whatever you want to do, and try it. He supported me, but he was looking at me like, you are crazy. Like, we were having our third kid. I was studying a master. um, but whenever someone asked me, how could you manage? I always said, it was not me. We were a team. We worked together. He was supporting me. He was my backstage, and we were a team. And this is how I think that, even though there is a lot to do in terms of reconcile as a society, there is a lot to do also in terms of what we can do at home. So, um, what happens? I think that what happens many times is that um, without even talk about it, suddenly your career takes a second place while theirs is still there. And then, but then, in my opinion, when you go with you having children, and it's like a project that two adult people have are there in this project. Um, So it has to be 50-50, and everything has to be there, right? And we have to fight for that. And nothing wrong here. I'm not saying that it's bad that a woman, the mother, wants to be at home. Or I met two couples in my circle where it's the man who is there. The woman is going to work and he is taking care of the kids. They are taking care of the kids. It's not that that's not good. It's just that if you want to make your if in case you want to have a career, and in case you want to work on that career, and it's important to you, it has to be as important as your husband career, and you have to make it work as a team. So let me go now to the second part of my talk, which is about what I've been doing all these years. So, data science, I in genomics, right? This is what I started doing, like CSNP, select your SNP. That was a tool that I did for my first master in bioinformatics and in the group in the Pompeu Fabra University. So this is the only image I found because it's it's from some time so long ago that I don't have it. It's not available anymore, the web page. But basically, nowadays also I think that everybody knows about mutations in the genomes. Um, so we all have them, right? Like those are what makes us different, to have variations in our genomes. So sometimes combinations of those variations may have an impact on phenotypes or on diseases. And that was a tool for being able to choose ones that were more relevant for any study, maybe for a cancer study, maybe for another disease. Um, so you cannot look at all variants, you have to choose. And for that, you use statistics, you use algorithms that allow you knowledge, that allow you to decide, okay, I'm going to start with these variants that are, or mutations that are in in these genes, right? That was my first project. And then this was something that I did in my thesis, which was also kind of similar, like summing up, simplifying it very much. But the idea was like we have thousands of genes in our genome. We cannot look at them all one by one. So we need for that is what we use. We have data, then we use the statistics, and then we can choose some genes. Those genes, then we can look at them one by one, but maybe we are choosing like 100 genes. So in that case, what I was more interested, this is one gene, this is like the representation of one gene. And here you can see like in red or yellow, there are different variants. Those are variants that are between us and macaques. The genome, this will be like the genome of a macaque, and those are another human, right? There are no variants. They are like the reference genome. So, well, in fact, here you can see the macaque ones, and then I was interested in look at genes that have more than one um, variant, like in their genome, more like one possible set of variants, right? So I wanted to show that because it's not only data that you analyze with the statistics, but then you need to, and that I think that right now it's everybody knows it in data science, visualization of what you are doing. That I did it by with R. This is a plot doing with R, where I put all the information, right? Um, it's really important not only to get results, but to being able to check them. And the way to check them right nowadays is by visualization. So for many years later, well, apart from those specific projects, I was working in many other projects, analyzing duplications also in the genomes of different species. For instance, in the gibbon genome, on the elephant shark. I was also part of a study of a project analyzing dog copy number variation. This was I was co-directing it with Tomas Marquez. And apart from that, I chose some of them here, but I work also in the melon genome, in several other projects. At the end, all of this is data. You have a question, you have lots of data. You need to choose to be able to answer your hypothesis, um, and you need to be a little bit of have a little bit of imagination, using the statistics and being able to show what you are doing, right? So later in my first postdoc, I work on this. Um, we analyzed genomic data from Africans, different tribes, different African, to study the genomics in Africa is really interesting. So many years ago, the all the possible variants that we found outside Africa came from a subset of variation that was in Africa many years ago. So a subset of people from Africa, they move out of Africa, is the out of Africa, and from this subset of people is what we observe in the rest of the world. But there is a lot of history before that in Africa. So we wanted to analyze data from different communities, different tribes with different languages, different um, l- um, we have hunter gatherers. So and we applying artificial intelligence methods, which is normal, is used in evolutionary biology. We try to understand what happened many years ago, even with genomes that you don't have them, like extinct genomes. So our genome is like a roadmap of what happened, and we try to discover it, like reveal it with artificial intelligence methods, right? So then I moved to the United States and to a neuroscience department. And there I chose this project where in that case we wanted to check the difference between how it is expressed, different genes that are expressed differentially between different regions of the brain. There are different regions on the brain that they have different functions. So the nice there is this the nice of this so this plot is so nice because you see here those are the regions in the brain, real so we identified different genes that were differentially expressed. They were picked from the genome, they convert in transcripts, and they were expressing in the cells. And with that, plotting, doing a principal component analysis and analysis for visualization, we observed that we were able to identify like plot like the same pattern frontotemporal axis, right? We were able to, those were the genes that were differentially expressed from the others, and the others from, we were able to plot keep the structure of the brain, only using those genes that were differentially expressed in these regions. And in fact, we related those genes with retinoic acid, and from then there are a lot of analysis done in the lab, right? But it was quite nice. So finally, I've been right now. I'm in espresso, as I told you. I'm not. I've been there only for 3 months or 4 months, but still, at the end, there is a lot of data about the customers, and we want to analyze them, this data. And at the end, it's kind of similar things. Some people ask me, why are you there? Um, well, I am applying the same. For instance, this plot that I'm putting here is for single cell data. Right now, you can have the genome of each cell, in particular of transcripts, because the genome of a person is always the same, but the transcriptome, and then you have all together this data, but then you need to clarify what is what, and then there is a lot of these are clustering the genome, the cells, single cell clustering, right? So you can know that this cluster, this green thing, is come from a specific type of cells from the brain. Well, maybe neurons, maybe glia, things like that, or the blood, right? Or whatever study you are doing. So I want to. So in terms of clustering customer behaviors, we can apply all this at the end. It's the same. It's data and applying algorithms that from artificial intelligence or descriptive analysis. But at the end, even the questions are different. The data itself, how you analyze the data, is quite similar. So even if my path has been so always in biology, in genomics, in neuroscience, I can apply all my knowledge, or what I've learned to coffee, to the analysis of the customer's behavior, right? So that's it for now from me. I just want to finish saying, well, again, thank you for the invitation to the organizers of this event. I think that events like that are really important for this starting point that I was talking before, just to help other help other women to know that we can do it. We can work on all this. We can do whatever we want. Just there are some limitations and some moments, but we can do that. And also the other point that I would like to highlight is that even if you don't feel like what you are doing is exactly what you would like, just finish it as the best you can, and then maybe the next step is as good as the one you are in that moment. Okay, that's it.
Thank you very much, Belén. It has been really interesting. Personally, I would like to thank you for that presentation. For me, the approach that you gave at the beginning within your personal path and the Newton Raphson method has been super interesting. I think that it's a good way to explain how things could be different if you start from a different point. I studied aerospace engineering. I know about the Newton Raphson method, and I think it has been a really nice approach and a really nice explanation and a really nice link between your personal life and a mathematical method. So thank you very much for that. I think that it's really interesting, and I would like to raise the point that how important is the initial point, right? And I would like to link that with what are we doing now here today. As you said, your mom has been a role model for you, a woman that did what was not expected to be done as a woman at her moment. You were surrounded by different siblings everybody was doing technical stuff. So for sure, your starting point was perfect to encourage you to do whatever you want, even if it was not set to do so, right, as a woman. So I think that message is really important. The fact that having role models and having people that surrounds you, making you feel comfortable and making you feel that you can do whatever you want, it's really important. And it's the real lack that we have today within the tech industry, but for sure in other industries, regarding the gender gap in STEAM, basically, careers. So
Exactly.
thank you very much for this approach. I found it incredible. So thank you for that. And if you want,
Thank you.
I will ask you some questions that the public has.
Okay.
So first question: what do you prefer, academia or industry?
So this is so to me right now, I'm in my local maximum. I don't know if I can be in another better than that, but right now I'm doing what I want. I'm really happy in where I am. So maybe I wouldn't be there if I haven't been studying so much. So there are things that I wanted to say, and now I am like going deep into the what you are doing, analyzing, studying. All my path took me there, and I know I am so happy to be here now in Espresso. I'm lucky also because I've been involved. It's a new group that is formed of data scientists, um, and I really love the group. It's the boss, our boss, the people. We are four of us. Um, Honestly, I couldn't be happier. But it's what I tried to say at the end, right? Like even there I started thinking that didn't want to be in academia. I think that my first the first time I started doubting about it was in 2009, but I think I stayed there for 10 more years. um, but I always tried to do the best I could, even if there were moments that I said that I was struggling when I was a mom for the first time, right? Um, but to me, and I'm pretty sure that to other person is not like that. To me, I am really happy right now. I am doing what I want. I love data, uh, and I can apply it in a company, in a really nice company. So I cannot be more happier.
Okay, thank you. I am happy to listen that for you. Another question: do you think that U.S. approach is different from European one in the academia?
So I went to US twice. Well, three times in fact. In 2009 and 2010, I spent 8 months in Seattle, in the University of Washington. My boss there was like it was part of my thesis, and my boss there, he was Canadian from Canada. Um, when I went to the US, to Yale University, my boss, he was European, so he was from Croatia. So even though I've seen like the US in Seattle, I think I saw like the US style in research. I also saw my stay, my 4 years stay in Yale University was also with a European. There was mix,
Okay.
right? Um, but still, what I could say is that when I was in Seattle, my impression was that there were people was very focused. They were working hard, but here we do. But people is the same. So people we were not less than them. Like here there are places where we do really good science. In particular, well, it's true that I was in a very good group here in the University of Pompeu Fabra. It was so there are more coffees here. We stop more, but then the hours are longer. We work until late. But that doesn't mean that we do a worst work.
Yeah.
This was my impression,
Okay.
and that's it.
Okay. Yeah. Yeah. Thanks. It has been clear. Another question: do you
Okay.
consider the genetic algorithm to be useful for most of the problems you deal with at Nespresso?
I don't really understand this question.
That
So
the way I read it, or the question itself?
the question itself.
Ah, we can then pass it to
So
another
first,
one if you want, or you can try
no,
to answer whatever
I'm
you
going to
feel.
say something.
Okay.
Um, so first of all, I've been only working 3 months
Yeah.
here, in 3 or 4 months, so I didn't have a lot of question. What I'm not sure which this genetic algorithm it is. I'm not sure if it what I was showing there, but my only point there was that all that I have learned in my previous steps, research, I can kind of apply in a company. That so to me, this is something also that I wanted to say. Doing a PhD and working in research, particularly, gives you a lot of things like. We learn how to go deep into the problems, how we spend many times like working hard is not only that you work for someone, is that your work goes to yourself, right? And then you learn how to not only to program, to try to solve, to try to solve problems, decision making, no, but also like, you have to communicate your results in presentations, you have to communicate your results writing, so you got lots of skills, and I think that those skills are going to help me a lot, where I am now. So even if the path is not like the usual path, sometimes just like, a data scientist in academia, you can then reconvert into a company and be very helpful, and also like, being innovative, right? Like that's why that was my point there, that, um, the thing that I know about clustering in single cell, which nobody will think about it when you were working on coffee, allows me to make the maths and try to apply these different algorithms um, to another field completely different.
Okay. Another question. Do you consider that it's difficult as a data scientist to have background on the topic in which you are working on? Like, for example, if you are working for pharma, or if you are working for a bank, or if you are working, do you consider that the lack of knowledge about the industry itself could be a problem for a data scientist, or not?
Well, I do think so, depending on the, yeah. So it is exactly what happens to me in biology, right? Like, I'm a mathematician. I love computation. I love algorithms. This is my thing. This is what I really like, data, and I have a matrix, and I want to analyze that. But when you are working in so high level labs, in both here or in the United States, doing so specific so hard and specific things, and you don't have all this background in biology, for instance, is really hard. I mean, there are people that do. I mean, but to me, it was like, I feel like I there was a lack there to me, right? Um, so moving to Nespresso, and that's one of the reasons that I am happy about that, is that, so first of all, we are I'm one reasons for having the data scientists in the companies instead of always going to an external companies, is to learn how the company works. But it's much more easier to learn how the company works in terms of selling coffee, that to know all the theories about biology, right? So I think it's important not to be only focused on on the algorithms or the data itself, but you need to understand the background, and you need to collaborate. It's important to collaborate with other people, with the people that know the data. But then, depending on where and depending on the background of the field, could be easier or more complicated. But yeah, for sure, we need to understand the data.
Okay, thank you very much, Belén. It has been everything. We have you have solved all the questions from the public. Thank you very much for your intervention. Thank you very much for your time. It has been a really fulfilling and interesting talk. Thank you very much. I hope to see you soon. And once again, thank you very much for being part of the International FemHack.
Thank you so much, Noelia. It has been a pleasure to work with you.
Thank you very much. For the public, we will be back after the break in 2 hours. See you now. Bye bye, Belén.